Hey there guys, this is Mr. Parkins. Today we're going to be looking at our 9.2 section, which is ellipses. Like Miss Allahan, this is my first one of these, so please bear with me. I hope to do okay for you guys. So what we're dealing with here, like I said, are ellipses. Now ellipses look like ovals, so it's either like that or like that. We're not going to be tilting them at all or anything, so it's basically going to be a horizontal stretch or a vertical stretch. The two main things in this chart we want to look at are our standard form, and the way the book and this note sheet happens to talk about your standard form is the A value is always the largest number. So if you look at this first one, the A is underneath the X term. That means that the ellipse is going to be stretched horizontally more than it is vertically. In the second equation here, you have the A underneath the Y term, which tells us that the vertical stretch is going to be more for the ellipse. So that's the main difference with that. The center, like we've seen with most of our equations this year, is H and K. The major axis vertices and minor axis vertices, those equations, I think that will make sense to most of you guys as we start to graph them, so I wouldn't worry about those too much. For the foci are basically, there's a mini equation that you have to know for them, and again, I wouldn't get bogged down in the A's and the B's. It's basically the larger number minus the smaller number. If you look here at our square roots, you can't have the larger number second, because if you had the larger number second, that would give us a negative under the square root, which we know can't happen. So that's what we're looking at with the two of those. There are two foci for each ellipse. The foci are located inside the ellipse, which probably seems pretty standard. The one thing I would say about the foci is they're also always on the major axis. Okay, so when we have a major axis of an ellipse, the foci will always lie on that major axis. Okay, time to look at a couple of examples. Let's take a look here at example 1. Now, the first thing I noticed looking at this one is we don't have any shifts at all. So the numerator is just x squared, just y squared, so that tells us that our center is not going to be shifted, so therefore it's just going to be at 0, 0. Okay, so that's pretty straightforward. Now, looking at the major and minor vertices, I like to always go to the bigger number first. And when I say the bigger number, I mean looking underneath in our denominators. So what we have here, you got a 25 underneath the y squared. Like we saw with circles, remember we had to square root the number that was over on the right side in order to give us the radius? Well, we're going to do the same idea here. So what I look at that 25, and I basically think about that being 5. Alright, so our movements, and again, because it's under the y, it's going to be in the y direction, so up and down. Our movement is going to be up 5 and down 5 from the center. Okay, so we start at 0, 0. We would go up 5 to give us a point there. We'd go down 5 to give us a point down there. Okay, so that's going to help outline our major axis. Okay, going with the minor axis now. Okay, so similarly we'll just look underneath the x. Underneath the x we have a 4, so that tells us, again, square root of that is 2. We're going to go right 2 and left 2. Okay, so there are the 4 points that are outlining our ellipse. Now we're ready to go ahead and actually graph it, so I will try my best here, touching the points like so. And not too bad. Alright, so that's what our ellipse would look like. So after you have it drawn, it's pretty easy, I think, to do your major vertex and your minor vertex. Okay, they're asking for the length there for these two examples. So the major vertex length would be from the top down to the bottom. That would be a length of 10. Okay, so we have a length 10 for the major vertex. Minor vertex going across the middle there, we have a length of 4. Alright, now, for the foci, we need to use that little equation that we had up above. So if you look back up in that chart, if you need to, just kind of rewind this and check it out, we're going to have to use the a squared and b squared to help us figure out the c. So again, c is the square root of b squared minus a squared. You don't really need to know which one is b and which one is a. All you're thinking about here is the bigger number minus the smaller number, so that shouldn't be too hard for us. So c is the square root of 25 minus 4. So c ends up being the square root of 21. Okay, now for purposes of graphing those points for the foci, what I would probably do for that is just estimate 21, or the square root of 21, which is going to be between 4 and 5. So we'd be basically from the center of the ellipse, we'd be going up a little bit more than 4. Right about there would work, I think. And then same thing down on the bottom side. Like we said before, the foci are always going to lie on the major axis. Okay. Now, in terms of stating what the coordinates of the foci are, which I think is what they're asking us to do here. It's basically just the coordinates. Okay, so if I want to give both of those coordinates at one time, I would call them 0 plus or minus the square root of 21. Okay, one thing you'd have to be careful about, if that is able to be simplified, that square root, we would want to do that. Okay, so that's our example. That's your first ellipse that you've ever graphed. Okay, now we'll take a look at one where we have a little bit of shifting involved, so I'm going to skip ahead here to number 3. Sorry about the type on that. This numerator here should be x minus 2 squared. Okay, so we'll just deal with it that way as we go along here. So now if we think about the center is going to be shifted a little bit. Okay, so again with that shift there attached to the x minus 2, that's a shift to the right 2. Okay, because it's the opposite of the sign that's inside there. Now the y is a y plus 1, so it's going to be a shift down 1. Okay, so that's what we have for our center, is the point 2, negative 1. Not a terrible idea to just go to your graph and plot that point. Okay, so 2, negative 1 will be right there. That's not going to be on my ellipse, but it will be the center of it. Okay. Now the rest of this is pretty much like what we did above. We're going to do our up and down shifts, not shifts, but our up and down stretches from that, and our left and right stretches. Now the one thing that looks a little bit strange here is the y plus 1 squared doesn't have a denominator. So if that's the case, you just want to put it or visualize it as being over 1. Okay, and then we'll handle that from there. So major vertex, again, is going to be the number underneath, or the larger of the two numbers. That's 16. That's underneath the x. So now because that's underneath the x, that's going to tell us that it's a stretch left and right. Okay, so square root of 16 is 4. So from that point, I'm going to go right 4. From our center point, we go right 4, and then we go left 4 to there. Okay, so we're going to have a horizontally stretched ellipse in this case. Alright, now the y, because there's a 1 underneath, we go up and down 1. Okay, so that's just going to go to there and to there. So you can see we're going to have a really narrow ellipse here. So let's just connect those and sketch it. Okay, there's our ellipse. And again, major vertex is going to be the horizontal one. That's going to be 8. Because we stretched left and right 4 in each direction. Minor vertex up and down just 1, so that's going to be a length of 2. Alright, let's use our little equation here again for the foci. So what we have here is c is the square root of, I'll just put the numbers right in this time, 16 minus 1, so c is going to be the square root of 15. Okay, again, little estimation of that, if we had to graph them, square root of 15 is going to be between or almost 4, right? So your foci on this are really out towards the edges of the ellipse. The more elongated the ellipse is, and we'll talk about, it's called eccentricity, we'll talk about that later, the more elongated it is, the further out towards the edges of the ellipse your foci are. Okay. Now, to give the coordinates of that, and just for simplicity, I'm just going to give the coordinates of the rightmost focus point. Okay, so what we have there, if you think about where it is, it's to the right 2, and then it's over another square root of 15. So what we would do for the coordinate of that focus point is we would say it's at 2 plus the square root of 15. Okay, so that's the x coordinate of that focus point. The y coordinate of that focus point is just down at -1, so that's what we're going to have for the y coordinate. Okay, and then let's just do the other one while we're here. So again, it's over to the right 2 and then to the left radical 15. So the coordinates for that point would be 2 negative radical 15, or 2 minus, oh, you know what, let's fix that. Should not have that there, so that should just be 2 minus radical 15. Okay, for the x value, and then the y value again is down at -1. And again, if I lost you, that's for that focus point over here on the left. Okay, so that's what we're looking at for that one. Okay, so my class, I would like you guys to try out numbers 2 and 4 on this page. I think you'd be able to do them on your own. If not, we'll take care of it in class, but that's one thing I'd like you guys to try for tomorrow. But in the meantime, let's move ahead to the second page. Okay, so what we have here are ellipses that are not in standard form. All right, and if you look at the equations, you might not have any idea that they're ellipses at all, but we'll see how that works out. Okay, I'm actually going to skip number 1. We're going to go straight to number 2 here. Okay, so we had a circle example like this the other day where you had to basically complete the square. So we're going to do the same thing here with completing the square. All right. Now the tricky part here, we have a 9 as a coefficient in front of the x squared term. So what I'm going to look at right here, if I've got the 9x squared and the minus 36x, right, you want to group the x terms together. I'm going to factor a 9 out from both of those as I write them down. Okay. So what we have here is 9 parentheses x squared minus, that would be 4x now. Okay. Like we saw yesterday, I'm going to leave a space here for our completing the square steps next, okay, for the x variable. Okay, now we're going to do the same thing with y. So if you think about what we have here with y, you have a 6y squared plus 12y, so we will call that 6 factored out, y squared plus 2y, and then we're going to have, again, leave a space. Okay. Let's close those parentheses. We have the 12 over the other side, so we're just going to leave that as equals 12. Okay, so completing the square, hopefully after the circle examples the other day, you're more comfortable with that, and you can remember it from earlier in the year. So what we're going to be adding here is, again, half of the middle term squared, so the number that we're going to end up adding in that first set of parentheses with the x is going to be half of 4, 2, square it, 4. Okay, so that's going to be plus 4 there. With the y, we're going to have half of 2 squared, which is 1, so we're just going to have plus 1. All right, now we have to be really careful. Remember, we add that stuff over to the other side, right, to preserve the balance of the equation. But the fact that you have this 9 here as a coefficient, and then you have the 4 on the inside, what we're actually adding to the left side is not 4, but 36. Okay, so that's going to give us on the right side over here a plus 36. Okay, likewise, same thing's going to happen from that second set of parentheses. You have the plus 1, but the 6 gets distributed to that plus 1. So what we have here is a plus 6. All right, so that's what our entire right side is going to become there. Okay, so now in our next line, we're going to do our complete the square steps. So we've got a 9 out front over here. That set of parentheses will turn into x minus 2 squared. From the second set of parentheses there, we still got the 6 out front. We do the y plus 1 squared, okay, for our complete the square. And then if we do the arithmetic correct over there, that should give us a 54. Okay, now hang with me here. Remember, the standard form of an ellipse has equal to 1 on the right side. So what we need to do here is change that 54 to a 1, so the way we do that is divide through by 54. Alright, I'm going to erase this in a second, but I just want to show it to you this way first. So when we divide the left side by 54 also, what we basically end up doing, that's not going to go into our parentheses at all. It's really just going to affect the coefficient out front. So we're going to look at the 9 and the 54 and basically do that division. So what that's going to give you is 1 over 6. Alright, same idea in the next part. You got the 6 over 54. So that's going to give us 1/9. Alright, so let me just get rid of all that real quick. I think this should work. There we go. Again, what our denominators are going to become, we're going to have here the x minus 2 squared is going to stay in the numerator. The denominator is going to be 6. Alright, and then in this one here, we keep the y plus 1 squared up top, and our denominator becomes 9. Okay, right side is what we were looking for. Whoops, not 54. 1, right, because we divided by 54. So there's our standard form, and now we're ready to go from there. Okay, so like we did on the front side, we have a shift for our center. Our new center is going to be at 2, -1. Let's graph that. 2, -1 is right there. Okay, so that's going to be our center. Now, underneath the y, we have a 9. So again, we take the square root of that. Square root of that is 3. That's going to tell us to go up 3 and down 3 from our center point to give us the points on our major axis. Okay, now for the minor axis, we have something that we haven't really seen yet, which is a 6 down below. So again, you're still doing the square root. If it's not a perfect square, we still do the square root. So square root of 6 is going to be our stretch left and right from our center. All right, just estimate that for your graph. Square root of 6 is going to be between 2 and 3. So we're just going to come over 2 and a little bit, okay, to be right about there, and then left 2 in a little bit. All right, and that's going to give us our minor axis points. Okay, let's connect that for our ellipse. Close enough. Alright, so that's what our ellipse looks like. Almost circular here because you notice the two numbers are quite close to each other. Okay, so length of our major vertex is going to be 3 up, 3 down, so that's going to give us 6. Alright, now the length for the minor vertex, if you think about it, from the center we went to the right radical 6. Really just all you're doing is doubling that, so our minor vertex would be a length 2 radical 6. Okay, double radical 6. Alright, and now a little math to do for the foci. Foci is that C equation, so C equals the square root of b squared minus a squared, so that's 9 minus 6. So C here is going to give us radical 3. Okay. Now, again, the foci, this is an ellipse that's stretched in the vertical direction. So if you think about what the coordinates are going to be for our foci, the x coordinate is going to be the same as the center. So the x coordinate is going to be 2. And now what we have is in addition to the y value for the center. Okay, so the y value for the center was -1, and from there we go up radical 3 and down radical 3. Alright, so the highest focus point would be at -1 plus radical 3. Okay, and then the second focus point, change colors here to try to make that better, is going to be at 2. Again, it's -1 still, minus radical 3 is what we'd have for that. Okay, so there's the coordinates of our focus point, and there's that example completed. Okay, and again, my class, I'd like you guys to try out number 3 if possible. Again, complete the square steps, all that should follow very similar to what we did here. Okay, so I know I said we were going to try to keep these videos to about 15 minutes. We're getting close, or actually a little bit over than that right now, but I just want to show you guys this example real quick. Alright, this is kind of what we're going to deal with during class. We're going to take a look here at example 1. Okay, now I'm going to go through this kind of quickly, but the best way to do these, in my opinion, is to do a real rough sketch of what it is that they're telling you. Okay, so you basically have 4 coordinates there. I'm just going to come over here to the side and draw a little XY axis. Okay, and again, rough sketch. So what I have is a point -11, 5. Okay, -11, 5 is right about there. I have 7, 5. Okay, so 7, 5 would be right there. That is going to be, so those are endpoints of your ellipse. So if you think about it, all we really want from that is we kind of want the length of that, okay, in order to figure out where we're going. So if I'm at -11, I'm finishing at 7, that's going to be a length of 18. Okay, so I know that the length from here to here is 18. Okay, and if you think about what that's going to do for us, it's going to help us figure out the center. It's going to help us figure out the values that are going to go below our x term in the equation. Okay, other 2 points real quick are -2, 9, which is going to be up about there somewhere, -2, 9, and then we have -2, 1, okay, which will be about here. All right, so that length there, we want to do the same kind of thing. The length of that from 1 to 9 is going to be 8. Okay, so that's what we're looking at for the lengths on those. So the ellipse, I mean, if you had to sketch the ellipse, it would be pretty simple. The ellipse would just be this. Okay, and we'd be done. But we're going to have to do a couple little things here in the meantime. Okay, first thing I want to think about here is the center. Okay, so the center of our ellipse is going to come, oh, that's pretty bad. The center of our ellipse is going to come from basically the midpoints of the coordinates that you have there. Okay, so and however it is that you want to think about doing your midpoints, I got a -2, 5. Again, the vertical distance is 8, so you cut that in half, it's 4, and then I'm just adding 4 to the y coordinate from -2, 1. Okay, and similar idea for the x. So that's what we would have for our center. Okay, is -2, 5. Okay, next we want to think about the stretches, which is going to help us figure out the terms that go below the x and y values. So the stretch that we had, we went up and down, now I know the length is 8, but we went up and down 4 from the center, okay? And then we went left and right 9, right, half of 18. So that's going to help us get our values that are going to go down in our denominators. Okay, so now I think we're pretty much ready to go to the general equation and see what we got. So we'll just outline it here. We've got a set of parentheses squared, plus another set of parentheses squared, and we know that the right side of the equation has to be 1. Alright, so we'll go our denominators here. Now, first thing I would do is the center. So if it's a shift left 2, that's going to be x plus 2 inside here. Shift up 5, that's going to be y minus 5 inside here. Okay. Now, if our vertical stretch is 4, what we have to put underneath the y, because the vertical stretch is going to be the square of that. So we're going to have 16 go down below. If you wrote 4 squared, totally fine, all right, but it would end up being a 16 down there. And then same idea for the x, where we went left and right 9, so you got to square that guy, so we would get an 81 down there. And that's it. Okay, you don't have to do anything else. They're not asking for focus points, so we would stop at that point. All right, and that basically concludes our notes for today. Hope it was enjoyable, hope it helped. My class, if you could maybe try number 2 if you're bored and have nothing else to do, like I know you spend all your free time doing your math, but if not, no big deal. We're going to take care of that stuff in class tomorrow. All right, so hope you guys enjoyed it, and we'll see you in our next class.